Good evening, students. How are you all? Welcome to mathematics class. I am Kanika ma'am, your mathematics teacher. So, we started with the series of pair of linear equations and two variables from grade 10. And in the previous class, we were discussing elimination method. So, till now, we have discussed in detail about the consistency of equations. That means the equations which we have, do they have solution or they have no solution? We have also discussed the graphical method of solving a set of linear equations in two variables. Also, we have learned algebraic method for solving pair of linear equation in two variables. So, we have discussed substitution method in detail. We have discussed elimination method also. We have another method, that's an algebraic method for solving a pair of linear equations in two variables. That's cross multiplication method. So this cross multiplication method is there in the NCERT, but it's not there in the syllabus for this academic year. So we are skipping that for the time being. So we're not doing those questions, but then I'm discussing a few word problems today, which I'll be solving using elimination method, and some questions I'll be discussing on consistency of equations. So before we begin with, I'm going to first quickly revise the consistency of the equations. So now, a pair of linear equations in two variables in general form can be written as a1x plus b1y plus c1 equal to 0. Then we have a2x plus b2y plus c2 equal to 0. So this is the generalized form for writing a pair of linear equations in two variables. Now, consistency of the equations we are going to discuss using algebraic method. So we'll check here a1 upon a2 and b1 upon b2. We'll take out these ratios and we'll check whether they are equal or not. If they are not equal, that means a1 upon a2 is not equal to b1 upon b2. Then we will say that the set of equations, they have unique solution, exactly one solution. If we have a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2, this is the case of infinite solutions. Infinite solutions. That means the set of equations here, they have infinite solutions. If we have a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2, in this case we have no solution. We don't have any value of x and y which is going to satisfy both the equations simultaneously. Now in first two cases we will say that the set of equations is consistent. And in this case, we will say that the set of equations is inconsistent. So when we have solution, whether unique or infinite, we will say that the given equations are consistent. And if we don't have solution, we will say that the given equations are inconsistent. Now we'll discuss a few questions here based on consistency of the equations. So these questions I've taken from NCERT. Which of the following pairs of linear equations has unique solution, no solution, or infinitely many solutions? So this is the first pair of equations I have. I name this as equation 1 and this as equation 2. So if I compare this with the standard form, that's a1x plus b1y plus c1 equal to 0. Then if I have a2x plus b2y plus c2 equal to 0. Then I can say a1 is the coefficient of x here, that's actually 1. b1 is the coefficient of y, that's minus 3. c1 here is constant term, that's minus 3. In the same way, a2 is 3, b2 is minus 9 and c2 is minus 2. So now we'll just see, we have a1 upon a2 as 1 upon 3, b1 upon b2 as minus 3 upon minus 9, that is 1 upon 3. Then we have c1 upon c2 equal to minus 3 upon minus 2, can also be written as 3 by 2. Now as we can see, these two are equal, but this is different. That means a1 upon a2 is equal to b1 upon b2, not equal to c1 upon c2. So this is the case of no solution. The given set of equations has no solution. So the given set of equations is inconsistent. I hope students you've all understood this. Now let's discuss the next question. We have here 3x minus 5y equal to 20, 6x minus 10y equal to 40. So this is the first equation, this is the second one. So let's see. Here we have a1 upon a2 as 3 upon 6, that's 1 by 2. b1 upon b2 as minus 5 upon minus 10, that's 1 by 2 again. c1 upon c2 as 20 upon 40. When we simplify this, we'll get 1 by 2. So we have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. They're all equal. Just see, they're all equal to 1 by 2. So the given set of equations here has infinite solutions. Please notice here the given set of equations, they have infinite solutions. So the pair of linear equations which we have is consistent, and then we have infinite solutions for the same. Now students, let's discuss the next one. Let's name this as equation 1 and equation 2. So here we have a1 upon a2. That's, we are taking out the ratios of coefficients of x. That's 1 by 3. b1 upon b2 equal to minus 3 upon minus 3. That's actually 1. So clearly here a1 upon a2 and b1 upon b2, they are unequal. a1 upon a2 not equal to b1 upon b2. They are unequal. So when we get both of them unequal, we need not worry about c1 upon c2. That's not required to calculate in this case. So we can say that the given set of equations has unique solution. Yes, we have solution and exactly one solution. So the pair of linear equations is consistent in this case. Now let's discuss the next one. Here we have 2x plus y equal to 5. 3x plus 2y is equal to 8. Here, this is the first equation. This is the second one. So a1 upon a2 here is 2 upon 3. b1 upon b2 here is 1 upon 2. So we know a1 upon a2 is not equal to b1 upon b2. So this is the case of unique solution. This is the case of unique solution. The set of equations has exactly one solution. Now when the set of equations has exactly one solution, we can solve for the same also. Let's solve for this one. Let's try for this one. We'll do it by elimination method. So now we are going to make the coefficients of x and y, either x or either y, same. So here I'm finding this y convenient because I just have to multiply this by 2 so that I get 2y here. So I'm going to take first equation and I'll multiply this by 2. So I'm going to get here 4x plus 2y is equal to 10. That's the third equation. So instead of the first one, now I'll be using the third one. Now I'm writing this second equation as it is. I have 3x plus 2y is equal to 8. That's the second equation. Now very conveniently we can eliminate here y and we will have to subtract in this case. So I'm subtracting equation number 2 from equation number 3. So I can mention here on subtracting. Now we have 2y minus 2y, that's 0. 4x minus 3x, that's x. And 10 minus 8, that is 2. We have x is equal to 2 here. Now we can pick up this value of x equal to 2 and we can put it in any of the equations, 1, 2 or 3, any one of these. So I'm going to put x is equal to 2 in the first equation. The first equation here is 2x plus y is equal to 5. And then I'm replacing this x by 2 and y will remain as it is, no change here. And this is 4 plus y is equal to 5. 4 will go on the other side and we will get y is equal to 5 minus 4. That means y is equal to 1. So therefore we have x as 2, y is equal to 1. You can always just go back and check here whether your solution is correct. If you put 2 here and 1 here, you will get 2 into 2, that's 4, plus 1, that's 5. So LHS and RHS, they're coming out to be same. In the same way, you can put 2 here and 1 here. Let's see. This is 6. 3 into 2 will give you 6. 2 into 1 will give you 2. So 6 plus 2, that's 8. So again, LHS and RHS, they're coming out to be same. So hence we can conclude that x equal to 2 and y equal to 1 is solution of this set of equations. I hope students this is clear to you. Now let us discuss this one. For which values of a and b does the following pair of linear equations have infinite number of solutions? So please notice here two equations are given to us, but then these coefficients are unknown to us. So they're given in terms of A and B. We need to actually solve for A and B such that the given set of equations, they have infinite solutions. So I'm going to name this as the first equation and this as the second one. Now for infinite solutions, we know A1 upon A2, that is coefficient of x here upon coefficient of x here, equal to B1 upon B2, that is 3 upon A plus B, equal to C1 upon C2, that means the coefficients of the constant term. So we must have these three ratios same. In the next step, we are going to solve for A and B. So I'll take these two first. So if we take these two, we'll somehow try to find a relation between A and B. So we'll cross multiply here. This will get multiplied here and this will get multiplied here. So we will get 2 times of A plus B equal to 3 times of A minus B. So here we are going to take this 2 inside bracket and we will get 2A plus 2B, and this 3 will go inside bracket, we will get 3A minus 3B. Now we can take this A on this side, A terms on this side and B terms on this side. So let's see, we'll have 2A minus 3A equal to minus 3B minus 2B. So if 3A will go on the other side, the sign will get reversed. If 2B will go on the right hand side, the sign will get reversed. Now we will have minus A. 2A minus 3A is minus A, and this will become minus 5B. We can cancel out the minus signs and we'll get A is equal to 5B. Now this is one relation which I've got between A and B, and I'll be using this. Let's name this as equation 3. Now in the next step, we will combine these two. We can combine first and the last one also, that's okay. So for the time being, I'm actually considering the second and the third equations. Second and the third ratios. That means B1 upon B2 equal to C1 upon C2. So let's discuss this one. We have 3 upon A plus B equal to 7 upon 3A plus B minus 2. So I have just copied as it is 3 upon A plus B equal to 7 upon 3A plus B minus 2. Now I know that A is equal to 5B. I know A is equal to 5B. So I am going to replace here A by 5B. So we have 3 upon 5B plus B, 7 upon 3 times of 5B plus B minus 2. So this is 3 upon 6B equal to 7 upon 15B. This is 15B. 3 into 5 will give us 15. 15B plus B will give us 16B minus 2. Now let us multiply this here. In fact, before we multiply, we can do one thing. We can just make things easy for us. Oh, this is minus 2. 15B. We can cancel out this. So once the numbers are small, that is going to make the calculations easy. That's 2B is equal to 7 upon 16B minus 2. Now we are going to multiply this here. We are cross multiplying. We'll get 16B minus 2 is equal to 14B. This is a linear equation in a single variable, that's B. We'll solve for B here. This 14B we are going to take on the other side. It will become minus 14B. Minus 2 we are going to take on the right hand side. It will become plus 2. So we will have 16B minus 14B is equal to 2. That is 2B is equal to 2. And then finally we have B is equal to 1. Now we've got the value of B is equal to 1. We are going to go back here in the first equation and we'll put B is equal to 1 here. So when we put B is equal to 1, we will get A as 5 into 1. That's 5 itself. So we will put here B is equal to 1 in the third equation. We will get A as 5B. That means we will get A is equal to 5 times of 1. That means A is 5. So A is 5 here and B is 1. A 5 and B 1 are the required values of A and B, which is going to make the set of equations have infinite number of solutions. So if you put A is equal to 5 and B is equal to 1, you are going to get infinite solutions in this case. I hope students, you've all understood this. Now let us proceed, and now here we are going to discuss a few word problems based on elimination method. We solve them using elimination method, though you can use this substitution method also. Cross multiplication method we haven't discussed since it is not there in the syllabus for this year. So you can either use substitution method or you can use elimination method. Here we have a question. A part of monthly hostel charges is fixed and the remaining depends on the number of days one has taken food in the mess. When a student A takes food for 20 days, she has to pay 1000 rupees as hostel charges. Whereas a student B who takes food for 26 days pays 1180 as hostel charges. Find the fixed charges and the cost of food per day. Now in this question, it is given to us that a part of monthly hostel charges is fixed. So when you are availing the services of the hostel, you have to pay a fixed amount in any case. So let us take the fixed charges as rupees X. Now the remaining charges depends on the number of days one has taken food in the mess. So let us take per day meal charges as rupees Y. So this is for the food for 1 day. Per day meal charges we have taken as Y rupees and the fixed charges we have is X rupees. Now we have student A. For student A takes food for 20 days. So she has to pay 20 Y rupees for the food. Also she has to pay fixed charges, that is X rupees. So in all she is paying 1000 rupees. That's given to us in the question. In the same way, for student B, X rupees, in any case, she is going to pay as fixed charge and she has taken meal for 26 days. So she is going to pay 26 Y rupees for meal. And this much she is paying in all. This is also given to us in the question. Now we need to find fixed charges and the cost of food per day. So very clearly we can see that it's very convenient here to eliminate X because the coefficients of X, they're already same. So we are going to subtract these two equations. On subtracting, so when we subtract, the signs will get reversed. So they're all positive right now. They will all become negative. X minus X will give us 0. 20Y minus 26Y will give us minus 6Y. 1000 minus 1180 will give us minus 180. And in the next step, we have minus 6y equal to minus 180. I've just copied the previous step. Here, minus and minus will get cancelled. And then the 6 we can take on the right hand side. This will go in the denominator here. So we will get y as 30. So y is 30 here that we have got. That means per day meal charges we have as 30 rupees. Now we need to solve for the fixed charges. We are going to take this 30, y is equal to 30 and we'll put it in the first equation. You can put it in the second one also, that's okay. For the time being, we are going to put y is equal to 30 in the first equation. So we have x plus 20y is equal to 1000. We have x plus 20y is equal to 1000. We are going to then replace this y by 30. So this is 20 times of 30, that is 1000 again. Now this is x plus 600 is equal to 1000. This 600 will go on the other side. It will become minus 600. So we will get x is equal to 1000 minus 600. So x is finally 400. That means the fixed charges for the hostel we have as 400 rupees and per day meal charges we have already calculated in the first step, we have as 30 rupees. I hope students this is all clear to you. Now let us discuss one more word problem. So this is based on fraction here. Just give me 1 minute. So we've already completed this hostel question. Now let us discuss this one. I hope you can see my screen. You can see the question on my screen. A fraction becomes 1 by 3 when 1 is subtracted from the numerator, and it becomes 1 by 4 when 8 is added to its denominator. Find the fraction. So the question seems to be very simple here. We have a fraction. The fraction is unknown to us. Let us take the numerator as x and denominator as y. So this is about the original fraction which we are talking about. So the original fraction here would be x upon y. That's x upon y. Numerator x we have taken, denominator y. So the original fraction is x upon y. Now, according to the question, it's given a fraction becomes 1 by 3 when 1 is subtracted from the numerator. So if you take the original fraction here, x upon y, and you subtract 1 from the numerator, this becomes 1 by 3. So that's the first equation which we have. And the fraction becomes 1 by 4 when 8 is added to its denominator. So when you take the fraction here and you add 8 to the denominator, you are going to get 1 by 4. This is the second equation. Now from these two equations, we are going to solve for x and y. So we are going to take the first equation. We'll first simplify this. We'll cross multiply here. So when we cross multiply, we are going to get here 3 times of x minus 1 is equal to y. So 3 I have taken on the left hand side and multiplied this. Y multiplied by 1 will give us y itself. So this is 3x minus 3 equal to y. We have taken this 3 inside the bracket and we have multiplied with each term inside the bracket. Now we will get 3x minus y is equal to 3. Y I have taken towards the left hand side, 3 I have taken towards the right hand side. That is the third equation. I can just name this as the third equation. So instead of the first one, I am now using the third equation. In the same way, we will simplify the second equation. We will multiply this. This is cross multiplying. So we will get from the second equation as 4x is equal to y plus 8. Please notice 4 into x will give us 4x. Y plus 8 into 1 will give us y plus 8 itself. Now y I am going to take on the left hand side. I'll get 4x minus y is equal to 8. That is the next one. Now this is the simplified form for the second equation. So instead of the second equation, now I'll be using the fourth one. Now we have 3x minus y is equal to 3. We have 4x minus y is equal to 8. This is the third equation and this is the fourth equation. Now I'm going to simplify this. I will eliminate here y. The coefficients of y, as we can see, they're already same. So we are going to try to eliminate this y. But before that, we'll be subtracting. We'll subtract because we want to reverse the signs here. We want 1 minus and 1 negative. 1 minus and 1 positive sign. Then only this will get cancelled. So we'll write here on subtracting. When we subtract, this will become minus, this is plus, and this is minus. So y plus y will become 0. 3x minus 4x will give us minus x. 3 minus 8 will give us minus 5. So minus x equal to minus 5 will give us x is equal to 5. That means we have got the numerator, that is x is equal to 5. Now we'll take this 5 and we can put it anywhere. I am here putting it in the third equation. So put x is equal to 5 in the third equation. So we'll get here 3 into 5 minus y is equal to 3. That is 15 minus y is equal to 3. 15 will go on the other side. You will get minus y equal to 3 minus 15. So this is minus y equal to minus 12. So we have y is equal to 12. So the numerator here is x and the denominator we have solved for, that's 12. So the original fraction is 5 upon 12. X upon y, that is 5 upon 12. That is the original fraction. I hope students, you've all understood this. Let us now discuss the next question. This is also NCERT based question. Yash scored 40 marks in a test, getting 3 marks for each right answer and losing 1 mark for each wrong answer. So it's given to us that Yash has scored 40 marks. He scores 3 marks for every right answer and he loses 1 mark for every wrong answer. Now, this is case 2. Had 4 marks been awarded for each correct answer. So instead of 3 marks, if 4 marks had been awarded for each correct answer and 2 marks been deducted for each incorrect answer. So instead of losing 1 mark for every wrong answer, he would have lost 2 marks for every incorrect answer. Then Yash would have scored 50 marks. So this is the original case where he scored 40 marks. He got 3 marks for every right answer and he lost 1 mark for every wrong answer. But if the situations would have been different, that means if he would have got 4 marks for every correct answer and he would have lost 2 marks for every incorrect answer, then in that case, he would have scored 50 marks. We have to find the number of questions they were in the test. Now, let us take the correct answers. The number of correct answers to be X and number of wrong answers to be Y. Now we need to actually solve for the number of correct answers and number of wrong answers, because if we add these two, that's how we are going to get the total number of questions in the test. Now in case 1, where Yash is scoring 40 marks, he gets 3 marks for each right answer. So if he has given X right answers, then he will get 3X marks. For every answer, he is getting 3 marks. So for X answers, he will get 3X marks. Now he is losing 1 mark for each wrong answer. Losing 1 mark, that means -1 is a score. Now he is losing -1 for each wrong answer. So if he has given Y wrong answers, he is going to get how many marks would be deducted? -1 into Y. So that is -Y itself. So 3 marks for every correct answer and Y marks being deducted for all the wrong answers. How this is, I'll just write it in a different way to make you understand better. So it is -1 into Y. How is this? 3x, we have it's very clear that we have X correct answers. So 3x marks he has gained from correct answers. There are Y wrong answers. For every wrong answer, he is losing 1 mark. That is why I've written -1 here. So -1 times of Y is the marks which is lost from wrong answers. So his total score here is 40 marks. You can also write this as 3x minus Y is equal to 40. So let us name this one as the first equation. Now, in the same way, from case 2, we have had 4 marks been awarded for each correct answer. So 4 marks awarded for each correct answers. He has X number of correct answers. So he will get 4X marks. And 2 marks being deducted for each wrong answer. That means -2 marks for every wrong answer. So if we have Y number of wrong answers, we will get -2Y. That is 50. Now we can write this as 4x minus 2y is equal to 50. Also, what we can do here, we can divide this 2 out by 2. That is going to make the numbers smaller and that will make our calculations easy. So we can divide this 2 out by 2 and we'll get here 2x minus y is equal to 25. So we have written 4x plus minus 2 times y is equal to 50. This can be written as 4x minus 2y equal to 50. And when we divide this 2 out by 2, we'll get 2x minus y is equal to 25. This is the second equation. So these are two equations which we have. We will now solve here for x and y. So we have here 3x minus y is equal to 40. This is the first equation. And then we have 2x minus y is equal to 25. That is the second equation. We will eliminate here y because here the coefficients of y, they're already same. So we'll subtract here. On subtracting, when we subtract, the signs here will get reversed. This will become minus, this will become plus, and this will become minus. So you can eliminate this. Minus y plus y will give you 0. 3x minus 2x will give you x. 40 minus 25 is going to give you 15. So here we have x is equal to 15. That means we have x number of correct answers given by Yash. Now let us put x is equal to 15 in any of the equations. So I am putting this here in the second equation. In the second equation here is 2x minus y is equal to 25. I am going to put here 15 in place of x. I am writing 15 here. So this is 30 minus y is equal to 25. 30 will go on the other side. We are going to get minus y is equal to 25 minus 30. So we have minus y is equal to minus 5. And then we have y is equal to 5. Now we have x as 15 and then we have y as 5. That means the number of the correct answers we have 15 and the number of the wrong answers we have 5. That means the total number of questions, total questions in the test we have as 15 plus 5, that is 20 questions. We have 15 plus 5, that is 20 questions we have. Okay, I hope students you've all understood this. Give me 1 minute. So we have time. Let us discuss 1 or 2 more problems. So hostel question we have done. We've done this one also. Okay. Now, yes, we've completed this question also, the marks allotted question. Let us now discuss this one. We have places A and B. They are 100 kilometers apart on a highway. So let us draw the figure. Let's take the places here A and B, and they are 100 kilometers apart from highway. That means the distance between these two is 100 kilometers. One car starts from A and another car starts from B at the same time. If the car travels in the same direction at different speeds, let us say that they are both moving towards the right hand side here. At different speeds, their speeds are different speeds, and they are moving in the same direction in the first case. So when they keep on moving like this, let's say that they are meeting somewhere at point C. After 5 hours they are meeting. That's given to us in the question. Now this is the first case. I'm now just reading the first case and I'm trying to interpret this situation. I'm going to form an equation here. So let us take the speed of the cars here to be x kilometer per hour. So let us take x kilometer per hour as speed of the car which is starting from here, and y kilometer per hour as speed of the car starting from B. They are moving in this direction on the same side and they are meeting after 5 hours. So after 5 hours, 5 hours is the time. Let us see how much distance is travelled by this car. We know that the distance is calculated using speed into time. So speed we have taken for this one as x, and time we know after 5 hours. So that's 5x. So this car is covering 5x kilometer in 5 hours. That means this distance here is 5x. The car is starting from here and after 5 hours it is meeting here. So the speed of the car is x kilometer per hour and the car is traveling for 5 hours. So 5x is the distance. Distance into speed is the speed into time is the distance here. So this much distance traveled is 5x. In the same way, the car which is starting from this position has speed 5 km per hour and is also traveling for 5 hours. So it is going to cover 5y distance. So this much is the distance covered by this particular car, and because this much is the distance because I've taken this point C as the point of meeting after 5 hours. So here this distance is 5y. It is 5y because here 5 hours is the time and y kilometer per hour is the speed. So the distance covered here is 5y. We also know here AB, the distance between A and B, these two places, we have 100 kilometer. So this much is the distance covered by car A, this much is the distance covered by car B. They are meeting after 5 hours at this point. So this is 5x and this is 5y. Very clearly we can see that AC minus BC is equal to AB. AC is this, minus BC is AB. So let us put the values here. AC here is 5x, BC here is 5y, that is equal to AB. AB we already know is 100, that's given to us in the question. We can now simplify this equation by dividing throughout by 5. We'll get x minus y is equal to 20. That is the first equation. This is first case. So from the first case we've got first equation, x minus y equal to 20. Now in the second case it is given if the cars travel towards each other, they meet in 1 hour. So I'll again draw the figure. We have places A and B that's given to us. They are 100 kilometer apart. In the second case, the cars are traveling towards each other. So let's say that this is traveling here and this is traveling here. They're traveling towards each other. And if they travel towards each other, they meet in 1 hour. Now let us take the speed again as the same. There's no change in the speed. The speed of this car is x kilometer per hour. This is y kilometer per hour. Let's say that they're meeting somewhere at this point. I'm just randomly taking any point C. Please notice C is not the midpoint of AB. Nowhere it is mentioned in the question. C is any point. Let us take that they are meeting at point C here. Now, here, this car has speed x kilometer per hour. Let us take the distance traveled by this car in 1 hour. It is speed into time, that is x itself. So this much is the distance traveled by this car, that is x here. And this much is the distance traveled by car starting from B. Let us take this distance as speed into time, that is y. Y is the speed which we have already taken. Time we know is 1 hour, that is y. So this is the distance traveled by car starting from B. This is the distance traveled by car starting from A. And clearly from the figure we can see x plus y is equal to 100. X plus y, that is AC plus CB is equal to AB, that is x plus y is equal to 100. That is the second equation. Now we have got two equations in x and y. We'll solve for these two. So I'll just write here x plus y, x minus y is equal to 20. That's the first equation. And x plus y is equal to 100. That is the second equation. Now we'll solve using elimination method. It is very easy to solve. We can just cancel out this. We are cancelling because we are adding here. We are adding equations 1 and 2. So we'll get here 2x is equal to 120. So x is equal to 60. That means the speed of the car starting from A is 60 kilometer per hour. Now we are going to put this x is equal to 60 in the second equation. So when we put this x equal to 60 here, we'll get 60 plus y as 100. That means y is equal to 40 here. So the speed of the car starting from A is 60 kilometer per hour. The speed of the car starting from B is 40 kilometer per hour. I hope students you've all understood this. So alright students, so I am winding up here. So in the next class we'll do a few more questions based on elimination method, and I'll try to do similar questions, the questions which we have discussed today, like the questions which were related to the marks here and the fraction. So I'll try to do some more questions here for you.